All right, amigos, welcome back. In our last video, we discussed kind of the broader context of supply and demand and markets and kind of a top-level picture. Now that we have that foundation, let's dive in and analyze the separate parts of the model. And let's start today with the law of demand. Okay, so the focus of today, of this video, will be the law of demand. When we're talking about demand, remember, we're talking about buyer behavior. So you're going to want to be focused when you're thinking about demand on the incentives that buyers face, on the utility functions that buyers face, on the decisions that you yourself make when you opt to purchase something or not purchase something. Okay, let's jump in. The law of demand, let's get a definition first. This is an economic principle that states that there is a negative or an inverse relationship between price and what we're going to call quantity demanded. So the law of demand states that there is an inverse relationship between price and quantity demanded, ceteris paribus. As a result of this, demand curves slope downward. There's a few ways that we can express this law. We can express it through symbols. We can say, for example, that as P goes up, quantity demanded goes down. As P goes down, quantity demanded goes up. There's lots of ways to express this basic relationship, but it's critical that you know the relationship. As prices go up, quantity demanded for an item goes down, ceteris paribus. And vice versa. As prices fall, you're going to be more likely to buy something else. Again, ceteris paribus. Always remember that assumption, ceteris paribus. That means that we're keeping everything else equal to focus on these two variables and their relationship. The law of demand, just as an FYI, there's a lot of reasons for it. There's some common sense ones, but it really stems from two basic ideas in economics. The law of demand results from the income effect and the substitution effect. The income effect says that as prices rise, you basically have relatively less income. You know, if all prices go up, then your income, assuming it's fixed, is now worth less. So if prices rise and your relative income is worth less, your buying power is worth less, you're going to buy less. So prices go up, QD goes down. It's also reflected by the substitute effect. And the substitution effect suggests that we all have alternative ways to achieve utility. So if the price of an item goes up, we're going to be drawn away from that item and look to substitute items that will still satisfy our utility. So for example, if you're hungry, you want a pizza later on. You've got Papa John's and you've got Domino's to satisfy that pizza craving, right? After this boring econ, you need some carbs to just like pass out, okay? If the price of Domino's goes up, that will make Domino's relatively less attractive to you. You will seek out substitutes, other pizzas, like Papa John's, okay? You're gonna desire more of an item when it's relatively less expensive. So again, when the price of one item goes up, the QD, the quantity demand of that item, goes down as you favor relatively less expensive substitute goods, okay? So that's our law of demand. We can express that law of demand through symbols. We can also express that law of demand through what we call a demand schedule. A demand schedule is simply a table that indicates prices and the associated amounts that you will buy at that price. So in this demand schedule here, panel A and the demand schedule, we see that at a price of $30, Ann would desire to buy one pizza. If the price falls to $25, she'll want two pizzas. If the price falls to $20, she'll want three, and you get the idea. Notice that as the prices continue to fall on the demand schedule, the quantity demanded continues to increase. That reflects buyer behavior, that reflects our law of demand. So we know what the law of demand is. We know that we can express it through symbols. We can express it through a schedule. We can also express it through a curve. And all a demand curve does is it takes the values from the schedule and it plots them out graphically. So let me clean this up for us here. We see that at this point here, at a price of 30, Ann wants one pizza. We bring that over and we see at a price of 30, Ann wants one pizza, okay? Let's talk a little bit about the demand curve because we're gonna use those a lot, okay? So again, we said that the demand curve is a graphical representation of the demand schedule. Note the following. Number one, we're always going to put price on this axis, and we're always going to put quantity on this axis. The law of demand is making comparisons between price and quantities. So we're going to label our two axes with that. We always put price here. We always put demand here. We then simply take the different points. Price is 30, quantity is 1. The price is 30, we dot a line over. The quantity is 1, we dot a line up, and that gives us this point. You know, let's say that the price is 20. Ann wants 3. At a price of 20, we do a line over. Quantity of 3, we do a dotted line up, and that's this point here. So we can take the data from the demand schedule, plot it over, and get the demand curve. What we will do, in essence, let's get it cleaned up a little bit so we can show this clean. Once we have all the points plotted, we connect those points, and that becomes our demand curve, okay? There's a couple of important things I want to bring up right now. They're going to come back to us later, but I want to plant these seeds now. Number one, there is a difference between quantity demanded versus demand. Quantity demanded refers to one individual combination of price and how much you want to buy. At a price of 30, your quantity demanded is 1. At a price of 20, it's 3. At a price of 10, it's 5. So each of these individual combinations reflects separate quantity demanded points. When we plot them over here, each of these points is a quantity demanded point. So quantity demanded is one specific amount that's purchased at one specific price. It corresponds to one particular line on a schedule or one particular point on the demand curve. Demand, on the other hand, is all the quantity demanded points together. Demand is the entire function that wraps into it all the different data points. So each of these individual lines is a QD, but the whole schedule is a demand schedule. Each individual point is a QD, but the whole curve is a demand curve, okay? It's really critical that early on you understand the subtleties and the differences between quantity demanded and demand. Okay. The other thing I want to point out is that the demand curve can be used in a couple of ways. Once you have your schedule and you've plotted your curve, you can address it in two ways. You could say, for example, how many pizzas will people buy at a price of $30? So you could start here with the price, go over, hit the curve, go down, and say, yes, at a price of $30, people demand one pizza. So you can start with price, go over, hit the curve, and go down. But you could also go the other way. You could say, for example, what price would have to be charged if we wanted people to buy 3 pizzas? In this case, you start down here at the quantity. You say, we want to sell 3 pizzas. We want people to, if people want to buy 3 pizzas, what's the price have to be? You then go up, you hit the curve, you go over, and that gives you your price. So it's a really useful tool. You can address it, you can use it in multiple ways, including figuring out how much people will buy at a certain price, or going backwards and saying, if we want to sell this much, what price do we have to charge? Okay, so it's a useful tool. So I said it before, I'm going to go into it one more time. It's critical that you understand that quantity and quantity demanded are different. They have distinct meanings. Again, quantity demanded is the amount of a particular good or service that buyers are willing and able to buy, and here's the key, at one specific price. Demand is what consumers will buy at each and every price. So it takes the entire set of data points from QD and it puts them together. As we learned, demand can be represented with a demand schedule or with a demand curve. Okay, so that's our law of demand, and it manifests through the income and substitution effects, and it shows in a symbolic thing. P goes up leads to QD going down. It can be shown in a demand schedule. It can be shown in a demand curve. Okay, a couple of extensions of this that I want to put on your radar because they're going to come back to us later and they're good to get now. The idea of consumer surplus. Now, we talked before, I think, with the Wu-Tang example, although, you know, you decided to buy shoes. I don't know why you would if you can go see Wu-Tang, but that's another issue entirely. We talked about the net gain, and we talked about economic surplus, and we tied that in later to the gains from trade. Right now, let's formally break out a term and a definition. This term is consumer surplus. Consumer surplus is defined as the net gain or the economic surplus that a buyer gets when he makes a purchase. So consumer surplus is the net gain, the surplus, the net benefit, the overall social welfare that buyers get when they make purchases. And it is defined as the difference between how much a buyer is willing to pay and the amount that the buyer had to actually pay. And we learned this with the Wu-Tang example. It's not new. Okay, consumer surplus is the difference between what a buyer is willing to pay and the amount that they have to actually pay. So I bring this up now because once we have demand curves, we can actually graph out and map consumer surplus. Because let's think about our definitions. We said again that the consumer surplus is the difference between a buyer's willingness to pay. Well, a buyer's willingness to pay is simply the demand curve. And the actual price paid is simply the price. So if you are given, in this case here, a demand curve, and you know what the price is, consumer surplus graphically is the area below the demand curve and above the price. That's it. Consumer surplus, it's the difference between what you're willing to pay, which is the demand curve, and what you actually pay, which is the price. And therefore, graphically, the consumer surplus is equal to this triangle under demand and above price. Note that we can measure consumer surplus simply through the graphical triangle. I can just say, you know, show me the consumer surplus, and you would just shade this in. Note that you can also use third grade math. Remember that the area of a triangle is 1/2 the base times the height, and find the area of this triangle, which would be 1/2 of the base, which is 3, times the height, which is 35 minus 20. And if you crunch that out, you would get the consumer surplus. So you can look at it graphically. You can also put monetary terms on it by calculating the area of that triangle, okay? Notice over here that consumer surplus, obviously by definition, will be affected by price changes, okay? That's really important to point out. This one shows it here. I'll show you another one here. So let's say that we have consumer surplus. And we're going to start with the demand curve. And we'll start with the price. And we know that, let's make this fancy so I can impress you. We know that the consumer surplus will be this area here. Okay, nothing new. Let's say that prices fall. If prices fall, we'll call this P0. And let's say that prices fall to a new price called P1. We draw the new price. And if you notice here, the consumer surplus will now have increased to this area. So when prices fall, consumer surpluses increase, which makes sense because the law of demand suggests that falling prices benefit consumers. So there you go. Notice that if I asked you to crunch this out, you would first start by calculating the original consumer surplus, which is this triangle here. We'll just call this, for the hell of it, A, B, C. You would then figure out the new consumer surplus at the new lower price, which is this one here, which we would call it, say, A, D, E. And since the new consumer surplus is ADE and the original was ABC, we would define the gain or the change in consumer surplus as the area BDEC, which is this right here. Okay, pretty easy manipulation of this. Okay, so that's what happened if prices go down. Now we can also make the argument about what would happen if price would go up. So let's try that. You can predict prices go up, not good for consumers, be able to buy less, we're not happy. We're going to predict that consumer surplus will fall. Let's figure it out. We start off with the demand curve and we start off with the price, which we're going to call P0. And we're going to have here a very fancy economics demonstration of highlighter. And here you go, consumer surplus. And we're going to call this surplus area triangle A, B, C. Now let's suppose that prices go up. Let's get a little different color here to P1. Prices have gone up. And there you go. You can see that now the consumer surplus, again, defined as the area below the demand curve and above the price, is now this area here, which we would call, let's say, ADE. Same idea, we're just going backwards. If you have this information, you can calculate out the value of lost consumer income, of lost consumer surplus based on that price hike, okay? So there we go. Couple last points I want to bring up. So we've talked about the demand curve and the application toward consumer surplus. I want to bring up one additional application, and this is the idea of elasticity. We're going to cover this in more detail later, but I want to introduce it now so that, again, as you take your bird's eye view of this material and you synthesize these elements, it makes sense to you, okay? Demand curves can be either elastic or inelastic. When we talk about elasticity and the concept of elastic and inelastic demand curves, what we're asking is, how responsive is quantity demanded to a change in price? Okay, the law of demand says that as price goes up, QD will go down, or as price goes down, QD will go up. The idea of elasticity takes that a step further and says, but by how much? You know, the law of demand says that these two things are responsive to each other. Elasticity says how responsive. The law of demand says that a change in P will affect QD. Elasticity says how big is that change, okay? The demand for a good is classified as elastic when a small price change causes a large change in QD, okay? That's really important. So an elastic curve, a small change in price, the triangle delta, not just an outstanding sorority full of fine young ladies, but the Greek symbol for change and the symbol for economic change. A small change in price will lead to a big change in quantity demanded. On the other hand, the demand for a good is considered to be inelastic when even a large change in price doesn't really have much of an effect on quantity demanded. So a good would be considered, or a curve would be considered inelastic when a large change in price yields a, we'll call this a fairly small change in QD. In other words, it's not responsive. Now, later on, we're going to go into this a bit more detail, and you're going to learn that there's a handful of factors that will help determine if a product is more elastic or more inelastic. Those are really tied to the idea of substitutes. But for now, I just want to let you know. The other thing I want to bring up, and then we'll wrap it up, we know what elastic and inelastic is in the context of demand and demand curves. Just as a shorthand rule of thumb, elastic demand curves tend to be more flat, and inelastic demand curves tend to be more steep. Okay, why, you ask? Well, let's do a little bit of analysis. Let's suppose that we start up here. We'll call this just price high. Doesn't matter what the price number is. We go across, we hit the demand curve, we bring it down, and we have the quantity that's tied to the high price. Okay, let's now say there's a tiny change in price, real small. We'll go to like right here. Call this price low. Drop this line across. We drop it down. We have the quantity low. You notice that because of the flatness of the curve, even a relatively small change in price has led to a bigger change in quantity demanded. It's responsive, it's elastic. In a similar fashion, let's start off with an inelastic good. Great examples would be things like tobacco, salt, medical care, crack. Okay, anything that's addictive, anything without a substitute, anything that you need to have regardless of price is going to lean toward more inelastic. Okay, let's say that we start off here with price low. We have this low price, we're going to go across, and this will give us this quantity. Now let's say that for whatever reason we decide to spike the price. Big jump in price. We go across, we hit the curve, we come down, and while there is a drop in quantity, there is one. That drop in quantity is relatively small compared to the drop in price. And in fact, if I had made this curve even steeper, we could have designed it so that a huge jump in price would have a very tiny impact on quantity demanded, which is the case for highly inelastic goods, addictive goods, essential goods, okay? So that's our idea. That's a lot for one lecture, so let's do a quick recap. We talked about the broad thinking of the law of demand, consumer buyer behavior. We learned there's an inverse connection between P and QD. We learned why. We learned that you can express the law of demand through a little formula or symbols, through a demand schedule, through a demand curve. And then we extended that to remember that there's a difference between quantity demanded and demand. Once we had that, we did two brief extensions, the idea of consumer surplus and the idea of elasticity. That's a good overview to the law of demand. In our next video, we'll jump over to the buyer side for the law of supply. See you soon. Thank you.